Hello, my name is Julian Richardson. I work in the Blue Prism AI lab, and I'm going to talk about some applications of AI in RPA. So, RPA is transforming the enterprise with rapid growth. AI is doing the same. For example, computer vision is being applied in medicine to diagnose illnesses like retinopathy from imaging. AI has been applied to industrial process automation. For example, Google and DeepMind's work on optimizing energy usage in Google's data centers. AI powers smart assistants which run on your phone or in a call center. It can be used for voice identification, recognition or transcription. It can be applied to recognize and understand text in documents. And new applications are being discovered every day, many of them relevant to RPA. If we look at the RPA lifecycle, Blue Prism's 5Ds, AI can be applied in the discover and describe phases to build processes. It can be applied deeply within processes in the DX or decipher phases, and we'll see some examples of that later. And it can be applied for managing processes, for example, intelligent orchestration and provisioning. So, just a few words about the Blue Prism AI Labs. We were founded about 18 months ago to understand how can Blue Prism apply AI to RPA. We have a mixed portfolio of projects, with some projects that we expect to enhance Blue Prism in the short term, as well as longer term projects to explore and build techniques to enable RPA to be better in 2 to 3 years. So today I'm going to talk about some of the shorter term projects. First, I'll talk about some work we're doing with Decipher and a major bank in order to automate processing bank letters. And secondly, I'll talk about a prototype, which we call TableSpy, which aims to make it much easier to read data from tables in Blue Prism. Okay, let's start with the document understanding. So, we want to apply AI to understand documents which are being processed in an RPA workflow. And of course, when we do have documents in an RPA workflow, we have the perfect opportunity to add smart processing. The first step is to use optical character recognition to extract the text from the original form of the document, whether that's a printed document which has been scanned, an electronic document like a PDF, or a scanned handwritten document. Then we use natural language processing to understand the purpose of the document and to extract key data from it. For example, if the document says, I want to change financial advisor from X to Y, the natural language understanding needs to understand first that this is a document about assigning a financial advisor, and then what are the names of the old and new financial advisors. Naturally, automate processing as much as possible, but it's critical to ensure that the processing is accurate. And the way to do that is to equip the machine learning with a calibrated notion of how confident it is in its results, so that when it's not confident, a human can be asked to check and, if necessary, correct the results of the machine's processing. And in that case, the human's input can then be fed back into the system to further train the machine learned models and ensure that the system will be better able to process similar documents in the future. The process, therefore, steadily improves over time. So, we're working on continual learning from demonstration. The first step is to perform optical character recognition to extract text from the document, whether it's electronic, printed, or handwritten. That extracted text is then fed to a natural language understanding module which classifies the text, determining both the type of the document, for example, a letter or a form, and the intent of the document, that is, what is the document writer trying to say or achieve. The system then recognizes relevant entities in the document and extracts them, together with labels indicating the kind of entity. entities in this context can be dates or account numbers in addition to names and other things. So a crucial step is for the machine learning system to return, in addition to its results, a calibrated confidence score. And then, if the system is confident in the data it's extracted, the results can be fed through to the rest of the RPA workflow. And if it's not sufficiently confident, the document and the machine's results are passed to a human to verify and possibly correct. Now, when a human verification step has been performed, we get maximal value from the work they've done by passing it back into the system to further train the model and improve the results for future similar documents. Now, when the system first sees a new kind of document, for example, suppose it had never seen a letter about changing financial advisor, then it won't be able to make confident predictions for that kind of document, and those documents will have to pass through a human verification step. But as that happens, the verification results get fed back as training data, the models become better and better, and more documents can go through the straight-through path. Now, let's talk about the verification step. So, accurate extraction of text from the document is, of course, key to be able to carry out any document understanding. So the first stage in verification is to correct any OCR errors. When that has been done, the next step is to identify relevant entities in the document. The natural language understanding system will already have identified some entities, and the user will verify and, if necessary, correct the entities, whether they're names, addresses, dates, account numbers, etc., and the user may add some that the system previously missed. In this example, in the middle of the right-hand side, there's part of a document requesting a transfer of money. And relevant entities here are the account from which money is being transferred, which has been tagged in yellow with an account from tag, and several amounts of money in different currencies, which have been tagged in red with an amount tag. Now, documents with different intent types may have some entity types which are specific to those documents, but many will be shared with many other kinds of documents. Once verification is complete, the corrected data extraction is then sent through to the rest of the RPA workflow. But in addition, it's sent back into the machine learning system as training data to improve future processing of that document and intent type. So, a couple of example documents. This first one is about a transfer of money. On the left, you can see the letter, and on the right, the result of the natural language understanding systems processing. So one thing which has been done here is that computer vision has been used to detect and remove the stamp, and this helps OCR to get a correct text extraction. Natural language understanding has annotated relevant parts of the text with appropriate tags. For example, we have tags for the date, the account from which money is being moved, and the amounts of money. Now, when the system is annotating the entities in a document, as well as knowledge about entity types which are specific to that kind of document, it also benefits from knowledge it has learned about entities which are shared in common with other document types. For example, names look similar whether they're in bank letters or online forms. So in this second example, we pass a handwritten document through OCR, and then we extract relevant entities. One phrase in the document has been annotated in orange with an intent tag to indicate that it's the source of the document intent, which in this case is a "don't double tax me" intent, which I think we would all agree is a rather important one. So, to summarize the work that we're doing on document understanding, we're working on improving natural language understanding capabilities for Blue Prism and Decipher. So, we'll be able to process handwritten text. We aim for zero configuration, so it will not be necessary to provide the system upfront with large numbers of training examples. And instead of brittle handwritten extraction rules, we use machine learning to do the heavy lifting, and an important point here is that the machine learning system will be able to supply a calibrated confidence together with its results so that the system can know whether a document needs to be passed through a human verification step or not. And lastly, when there is a human verification step, the results of that are fed to train the machine learning system so that it can get more accurate and more confident in the future. So now I'm going to talk about a different project, an early prototype called TableSpy. So the problem is that tables are very common in user interfaces, but extracting data from them in a workflow can be difficult. Different fonts or background colors can make it hard to accurately read the table's contents. If it's necessary to scroll the table to access parts which are off screen, then the workflow is likely to be very complex. And lastly, if the table changes, for example, new rows or columns are added, then the workflow reading the table is likely to break. The solution we're working on uses a computer vision server, which is a machine which may have more memory than a typical Blue Prism machine, and it may even have a graphics card. And we envisage this machine being on-premise so that the client data does not have to go outside their IT system. The first thing the computer vision system does is to detect the table. That means locate the table in an application. Then it analyzes the image of the table to determine where the rows and columns are. And finally, it interacts with the table, scrolling as necessary and processing image snapshots of the table with OCR to extract the data. So now I'm going to show you a demo in which we compare reading data from a table using TableSpy to a solution which uses Blue Prism's region mode. Again, this is currently a proof of concept, and we're not announcing any availability yet. So on the left-hand side, you'll see us configuring and running a workflow using region spy mode to read the contents of a table. So here, the user is identifying the regions of the table which correspond to data cells. And next, the user specifies the fonts which are used in the table. Finally, the user constructs a complex workflow which navigates around the table reading data. You might be able to see here that the scrolling is hard-coded, which results in this interesting structure to the workflow. So let's compare to TableSpy. And in the bottom left-hand corner, you see the user is continuing to build up a workflow using region spy mode to read the table's contents. And that process is speeded up by a factor of 50. If we didn't speed it up, then I think my talk would overrun. So on the right-hand side, we are importing a TableSpy object, and we're going to configure it to read the kind of table that we're interested in this application. So first of all, we have to tell TableSpy in what application it finds the table, and in this case, we're saying it's going to be a Firefox browser window. And next, we outline the bounds of the table and also tell it where the scroll controls are. And these controls will be used later in order to move around the table while extracting the data. So we hit Show Layout, and this runs the computer vision algorithm and allows us to see that the system has correctly recognized where the rows and columns of the table are. Okay, so let's save that object. And now we're going to use it in a process. Okay, so we're going to define a process, especially for Blue Prism World. There we go. So the configured TableSpy object provides 3 actions. The first one is to attach to the application where the table is displayed. The second one is to detect the table and the associated control elements. And the last action interacts with the data, with the table, and reads its data. So you can see at this point on the left-hand side that the user has been building the region spy mode for over an hour and a half, while we've been working for just a couple of minutes. So we need a couple of data items. The first one just stores an image of the table, so we can see that it found the right one. And the second one is a collection, which is used to store the results of reading the data. So we connect these data items to the relevant parts of the workflow, the table image, and the output for the table data. There we go. And it's done, no errors. We have a workflow, and we'll be ready to use it now to read data from a table. So let's suppose that works for a while, but a month later, we run the workflow, we find that the font size has changed, somebody added a new department column, there were more rows, and one of the rows even spread over multiple lines. Anyway, we're still going to run the process because we know Table Spy is robust to these kinds of changes. Okay, so the workflow is running on the right, it attached to the application, detected the table, and now you can see it's navigating around the table using scroll bars, applying OCR as it goes to extract the contents of each cell. Here it is, scrolling around the table in order to reveal the off-screen contents when necessary. Okay, so Table Spy has finished running, and let's see what data it extracted. So it got all the columns in the data, even the ones off screen, and even the new department column. And it got all the rows, even the ones which were off screen. So the region spy mode, building that solution took over 3 hours, whereas Table Spy did the job in just under 4 minutes, which is 50 times faster. So to sum up, we're designing Table Spy to be quick and easy to use, and this will enable processes to be automated where previously it may not have been economic to do so. It will use computer vision running in an on-premise server. It will handle complex tables with scrolling, different fonts and backgrounds, truncated columns, new and swap columns, and varying row heights. So, to wrap up, we see that there are lots of ways to apply AI to RPA in the 6 to 12 month time frame. Longer term, we see that AI can be applied to every phase of automation. Technologies like process mining and process discovery can be applied to discover processes and automate their definition. We can apply AI to analyze and optimize processes. And as we've seen, we can apply AI deeply within processes, and the possibilities for intelligent document processing in RPA workflows are particularly rich. Lastly, incorporating the human in the loop, using their unique expertise and abilities, can help to achieve the best results, and additionally be used to help train the RPA system to perform better and better in the future. So this concludes my presentation. Thank you for taking the time to watch.